Alright, so today we're looking at 8.3, part 1, and there's actually quite a bit that we need to do today. So the first thing we're going to deal with is actually writing quadratic equations when I give you the solutions. So normally you guys have to find the solutions. When I give you a quadratic equation, we're going to do the reverse of what's normal. The second thing we're going to do is we're going to use the discriminant to determine if it's factorable. So this is something that we have done before, but there's going to be an extra twist to it where you're going to need to factor. Then you're going to need to solve polynomial equations with higher exponents than 2. In other words, problems you cannot use the quadratic formula on. And you're going to need to solve polynomial equation with fraction exponents. So these two kind of link together as being one overall way to deal with those. But we are going to need to look at those, and these are probably the hugest pieces for today that you need to understand before you're done. So let's go back and look at an actual quadratic equation. If I asked you to solve something like this, you have a few ways of doing it. First, you have square roots, which we can't do because there's an x squared and an x. The other thing we have is factoring, and factoring is quicker than the quadratic formula if we can do it. So let's try to factor. So think about numbers that multiply to negative 24, but would add to 2. Well, 6 times 4 is 24, and if we make the 4 negative, they multiply to a negative 24 and add to 2. So we would say x plus 6, x minus 4 equals 0, right? And then we would set each piece equal to 0 and solve by doing the opposite. We are going to do this basic idea, but now I am going to be giving you this answer, and you are going to need to work backwards to find the original quadratic equation. So whereas before I gave you the equation, you had to factor it and solve, now I'm going to give you the solutions and you're going to have to work backwards. So really the idea is you literally are going to do everything but in reverse. Okay, so to write these, you're really just going to do these steps but in reverse. So step 1 is we're going to do an example over here as we go through it. If we look at this as 3 and negative 10 are my solutions, isn't that really saying x equals 3, x equals negative 10, just like what our last step was here? Well, before that, we had to have something equal to 0, right? So the idea is I need to find out what would this, I need to write a binomial like this that would give me this as a solution, right? So this is our step, right? First step, right? Binomial that gives you those two solutions. So in other words, if I wanted x to equal 3, what would this binomial have to be to get it to equal 3? Well, you can just think about it as x equals the solution, like what we had here. And now we don't want this to be the solution. We want this to move back over, right? So I can basically make it equal 0 to find out what that would be. So if I wanted to move this back over to make it equal 0, wouldn't we just subtract 3? So x minus 3 would equal 0. We could add 10 to make that one equal 0. So x plus 10 would equal 0, which sets up this piece right here. Now that we know that piece, right, we need to go back one step further. In other words, we're going to take those two pieces, multiply them together, and set it equal to 0. So that's step 2. You're going to write your equation as the binomial times the binomial equals 0. So in this case, our binomial is x minus 3. Our other binomial is x plus 10 equals 0. And some of you might be able to go right from here to this step and say, oh, if I'm going to get 3, it has to be x minus 3 so that I could add 3 to 3. If we had negative 10 here, it would have to be a plus 10 so that I could subtract 10 to get 10 as an answer. If you don't show these steps and you go straight from here to here, I'm fine with that as long as you understand how to get there. Now, I need to take this and go back to my original problem. In other words, we need to distribute to get rid of the parentheses. So x times x is x squared, x times 10 is plus 10x, negative 3 times x is negative 3x, and negative 3 times 10 is negative 30. Now we would just simplify this to combine our like terms, so this would be x squared plus 7x minus 30 equals 0. And I'm going to tell you right now, you had better make sure you have that equal 0 piece. This is where students frequently lose points on the quiz. It must be equal to 0. Otherwise, you could not have solved it to begin with. All right, so let's try that with these down here. What this is really saying is that we have x that's equal to a positive square root of 6, and we have x that's equal to a negative square root of 6. All right, this is just a fancy way of saying your two answers are square root 6 and negative square root 6. So in order to move that over, we would subtract, so we'd have x minus root 6 equals 0. In order to move this over, we'd add, so we have x plus root 6 equals 0. So our new equation is x minus root 6, x plus root 6 equals 0. And then we just distribute out. X times x is x squared. X times positive root 6 is x root 6. Negative root 6 times x is negative x root 6. And remember, when you're multiplying, these are both in the radical, so you actually multiply them out. 6 times 6 would be negative square root of 36 equals 0. Combine your like terms, positive and a negative, they cancel, so we have x squared. And remember, you can actually square root this 36. What number times itself is 36? 6. So x squared minus 6 equals 0 would be your original formula. Okay, number 3, same basic idea. This is really saying that my two solutions are positive 5i and negative 5i. So that means x equals 5i or x equals negative 5i. To move that over, we'd subtract, so we'd have x minus 5i equals 0. To move this over, we'd add, so we'd have x plus 5i equals 0. So our formula is x minus 5i and x plus 5i equals 0. Again, notice I keep saying equals 0, equals 0, equals 0, right? So now we can distribute out. X times x is x squared. X times 5i is plus 5ix. Negative 5i times x is negative 5ix. And be careful with this one. Negative 5i times positive 5i. Well, 5 times 5 is 25, but I times I is I squared equals 0. So positive 5ix, negative 5ix, they cancel, giving us x squared minus 25i squared equals 0. And this is where students will make the mistake, because you need to realize I squared is something we learned from before. And remember, I squared is equal to a negative 1. Huge, huge deal to remember from the previous unit. So we'd have x squared minus 25 times negative 1 equals 0. So then we can actually multiply those out and get x squared plus 25 equals 0 as your quadratic formula. All right, next one. The issue here is the fraction. The fractions are what are going to throw you when you do these types of formulas. So what I would tell you is this. Start out by setting it up the normal way. So we would know x has to equal 1/2. We would know x has to equal 3/4. Then we would move it over to say x minus 1/2 equals 0, and to move this over, we'd subtract, so x minus 3/4 equals 0. Okay? At this point, you can rewrite these if you want to, but I feel like since we have a calculator, as long as you have a calculator and you can multiply with fractions in your calculator, you should be fine. So I'm going to leave it like this. So x minus 1/2, x minus 3/4 equals 0. So now I'm going to pull out my calculator and I'm going to use that whenever I'm doing any of these problems with fractions. So x times x is x squared. X times negative 3/4 is negative 3/4 x. Negative 1/2 times x is negative 1/2 x. And now we would want to type this in our calculator because multiplying fractions is something that most of us are not very good at. So in parentheses, -1/2, -1/2 times, my next set of parentheses is -3/4, which would give me a decimal that I'm going to change back into a fraction, which is 3/8. So this is a +3/8 equals 0. Again, just like before, we should see some like terms here that we can put together. So I need to do -3/4 minus 1/2. So in parentheses, -3/4. Oops. -3 divided by 4 minus, in parentheses, 1/2. And then I'm going to change that back into a fraction again, which is -5/4. So I have x squared minus 5/4 x plus 3/8 equals 0. Now a lot of you will want to say this is your answer. No fractions in final. This is huge. So I'm going to need to multiply by the LCD to clear my fractions. So I have to think about what's the lowest common multiple between 4 and 8. And the lowest multiple between 4 and 8 is 8. So I'm going to multiply this entire thing by 8. So 8 times x squared is 8x squared. Then I have to do 8 times -5/4, which is -10x. And then I have to do 8 times +3/8. And we would get 3 equals 0. So if I were you, I'd wait till the end and clear the fractions at the last moment, because you do have a calculator that will multiply and add those fractions for you if you struggle. So at this moment, I want you to pause the video and I want you to try these 3 on your own, and then we will go over them tomorrow in class to make sure you're good with them. All right, at this point you should have tried those on your own. And now we're going to move on to our next topic for today, which is to determine if a quadratic is factorable. And that's something that we've already done. Remember we said, oh, we can find the discriminant, b squared minus 4ac. If that number is a perfect square, then it is factorable. Otherwise, it is not. So that's the thing we have to take away from this. So in these problems, it says determine if the polynomial is factorable. So that's our first step. This one, there is no zeros here, so we can just, a is the number in front of the x squared. Remember, b is the number in front of the x, and c is the number by itself. So then we'll do the discriminant, b squared minus 4ac, which would be -6 squared minus 4 times 6 times 1. So we can go ahead and type that in our calculator. And we would get 12. So 12 is my discriminant, so we have to decide, is 12 factorable or not? It has to be a perfect square to be factorable. In other words, I have to be able to take the square root of it and get an even number. I cannot, so this one is not factorable. Or, in other words, it is what we called from before, prime, because you cannot factor it. So let's do the next one as well. Determine if it's factorable. So there is no equal to anything, so we can just list out my a is 10, my b is 17, my c is a number by itself 3, b squared minus 4ac. The b is 17 squared minus 4 times a is 10 times c is 3. So we're going to go ahead and we're going to type that in our calculator. 17 squared minus 4 times 10 times 3 is 169. So if we can square root that, then it is factorable. So second square root of 169, we get an even number 13, so this one actually is factorable. Now this is where you need to read the entire instructions. If they are factorable, then we need to factor it. So now I need to go back to this original problem and try to factor that problem. In other words, I need to think about something and see, like, is this a multiply to the last, add to the middle problem? No, because my first problem is my first number, my a, is a 10. It's not a 1, so this is guess and check. So I have to think about numbers that could multiply to 10, which would be 2 and 5 and 1 and 10. I also need to think about numbers that would multiply to give me 3, which are only 1 and 3. So right away, the numbers I can put in are the 3 and the 1. I know that there's going to be an x in the front, but now I have to get out my pencil and do the guessing and checking like we did before. I don't have my pencil, so we're just going to use my whiteout as an eraser. So I'm going to guess 2 and 5 first, because I think 10 and 17 are relatively close together. So I'm going to guess those to begin with. So if I want to get to 17, maybe I'll put the 2 here and the 5 here and see if that will work. So 2 times 3 is 6x, 5 times 1 is 5x, 6 and 5 will not combine to 17, so that will not work. So then we're going to have to rearrange that. So then I can put the 5 here and the 2 here and see if that works. That would get me 15x and 2x, which indeed does get me 17x as long as both of these are positive. So my factorization is 2x plus 3, 5x plus 1. So you have to make sure you read the instructions. Sometimes it'll just ask, is it factorable or not, and then you can stop. But if it says, if it is factorable, then you have to factor it, then you'll have to go a step further. So, last one, right? Now be careful with this one. Normally it should be ax squared plus bx plus c. But if you notice, there is no just plain x term here. So I would rewrite this to be x squared plus, if I don't have x term, this is really 0 of those x's plus 25. That way, when I identify my a, I know it's 1. My b is 0 because there's none of those x's, and my c, the number by itself, is 25. I always like to add that in so that I remember what my b actually is. So b squared minus 4ac, my b is 0 squared minus 4 times my a is 1 times c is 25. Go ahead and type that in your calculator. 0 squared minus 4 times 1 times 25. And you get negative 100. Because of the negative, right, that means that this is not factorable. Because this would be an imaginary number, and you cannot factor imaginary numbers. You can only use the quadratic formula. All right, so you have 3 of those to try on your own before going to the next video to finish this out.